of the same thing. You guys understand? See how that's happening? Okay, we want to find a function f composed of g that's equal to h. So you create a function f that's pretty much the same as h at x minus some feature. In this case, we chose the absolute brackets, and then you make up for that feature in the compose function. So you take absolute bracket values of x. Okay, we could have done the same thing, letting g at x equal to part of that function, just x cubed, and then our second function, we would then subtract the minus 1 in all absolute brackets. Okay? So you're taking the original function, you're taking one piece of it, putting it into one function, and decomposing the second piece of it in another function. All right, in summary, two functions f and g can be combined using a process called composition, which can be represented by f at g at x. The output for the inner function g is used as the input for the outer function f. So the y value of the inner function is used for the x value of the outer function. The function f at g at x can be denoted by f composed of g. Okay, that's what that circle means, composed. All right, we need to know. Algebraically, the composition of f with g is denoted by f composed of g at x, whereas the composition of g with f is denoted by g composed of f at x. In most cases, f composed of g at x is not equal to g composed of f at x, because the order in which the functions are composed matters. What's the case when it is equal? It says in most cases it's not.
What is composed?
Right. If one of the functions, if the two functions are inverses of each other, then it does work. They are equal. Okay? Let A and B EG and B and C EF, then AC EF composed of G. A point in F composed of G exists where an element in the range of G is also in the domain of F. The function F composed of G exists only when the range of G overlaps the domain of F. Okay, so that's what we talked about when we were dealing with that example 3 in the domain. The domain of F composed of G at X is a subset of the domain of G. It is the set of values X in the domain of G for which G at X is in the domain of F. So again, that's that same sentence we looked at the last paragraph. You got to read it over if it's not making sense. If both F and the inverse of F are functions, then F, the inverse of F composed of F at X is equal to X for all X in the domain of F. And F, the inverse composed of the inverse of F at X is equal to X for all X in the domain of F. The inverse of F. Any questions? Want me to repeat it? Sounds confusing, but